The firefighter one, that one shouldn't have been terrible. I think that one gave you the two different distances that would have worked.
So basically you just plug them in and just find the zeros in the max.
Yeah. The firefighter's aiming at a good aiming a good water stream at a building's window of 25 feet above the ground, and what two distances can the firefighter stand from the building? So the water stream is that. Yeah, you've got two different values because the parabola. Yeah, it's pretty easy to go through that one. So what did you do for that one, Alicia?
Nothing, I didn't do it.
I thought you just said you did it.
No, I said you just plug it in and you find the max and the zeros, right?
Well, what he's looking at here, first of all, let's look at this curve. So let's put the curve in. So we have the curve for this one is y equals negative 0.003.
Yep.
X squared, help me out, plus 0.62x plus 3.
Oh, it found it.
So what you're looking at here is that if he's, you can get this thing to show up, change our window, maximum, I think 150, let's try that.
That'll work.
X, does it work that? I'm just guessing.
I'm pretty sure because I found it under like the table and it was like 103 or
I hit 5 again, not 50.
No,
You have to be
150
higher.
isn't there.
I know I hit 5, not 50.
200 actually.
200? Bless you.
For what, the Y max?
Yeah.
Oh, sorry.
X max 200?
Yeah.
Okay. What was the Y max you guys did?
100.
Does 50 work?
I don't know. 50.
You can use 100 if you want.
I think it needs to go past 200 actually.
No.
Yeah, it's like right there.
Looks like we might have to go, yeah, we're a little bit past 200, okay.
Jeez Louise. 220.
I thought I got it.
The only reason I'm not going all the way up to 300, which is fine, is that when I do my range checks, something, it would be a little bit less variance. I mean, it's going to be close enough. But, right. All right, so what this is showing us is that the curve itself is going to do this. And the question good fire stream, the x and the horizontal distance traveled from feet for aiming that. So there are two spots the firefighter can stand that it'll hit 25 feet up off the ground.
Congratulations.
Congratulations to the fireman. So the 25 feet off the ground is maybe right here and maybe right here. So there are two different distances that he can stand from. He can stand
Oh, I thought we were like this.
with the water stream, I think.
I thought we were.
Basically what you're looking for here, guys, is in your table.
I don't know.
If we scroll our table, we should get values in y
What are you looking for?
that'll be about 25.
26.
Was it 46? Okay. So we've got one at 46, right about 46 feet, and then we just go all the way around and find the other one. Now, one of the things you can do is that in the table, instead of scrolling through, yours isn't so bad to scroll through because it goes a lot faster.
But yeah, it's okay.
Mine's a pain in the butt because it's slow. I don't know why, but it is. What you guys can do is this. If you hit second table set, it allows you to pick a new value to start your table at. Right now, mine's starting at 43. I'm guessing since our graph went all the way over to 250-ish, I'm gonna pick 200 for my table to jump right to and just see what happens. And then it's just quicker, I can move from there up and down to my table to look for the other one. Obviously at 200, so I have to go up.
If you were to do 100,
Where is it at, 100? Oh, well, I goofed on that one. But you get the idea. I could change where I want to look at in my table and mess around with it. You guys, it's just as easy for you just to scroll up and down. Because your calculators, well, see how slow mine is to scroll? Yours is so much faster to do it, okay? And like I said, I have absolutely no idea why emulator software is this slow. It makes no sense.
So what would our engine?
First one was what, 46, and what was the other one at?
160.
There you go.
Huh?
And obviously there's,
Wait,
Yeah.
46? Yeah, but what, just write down the numbers, like what
So
do you
if
say?
it's like-
Like
if
what do
it's
you like label it,
multiple-
like it's not like,
Would we pick the closest one, 225?
yeah, you say like between, it's one of those things at about 46. And I know if you say 45.2 feet, I mean, I get it.
Okay.
I know what you're doing. Yes, ma'am.
There's 161.
the first two.
I'm sorry, I
two
couldn't
points
hear you.
that
What was
are
that?
both at 25. There's 2 points that are.
Which one, that Y value?
Two points that are like.
Oh, so you just look at your table.
It helps you to find values faster than instead of substituting in and looking for it in factoring. What we're looking at here is, in this problem, it was asking for us, if a fire, what two distances could he get to 25 feet? Bless you. This 25 feet is the Y value. So in essence, what you're doing is you're setting this quadratic equal to 25. So you're using your table value to figure out where does that work to be 25. It's faster than using the quadratic formula and going through that way. That's all. That's the only thing it is. What you're looking at is where does this function, where does this graph equal 25?
So how do I label?
What's that?
Just 40.
Why did you use the calculator?
So,
Because I just changed my table instead of scrolling through all of them to look for another 25. There's 2 values. I just figured it's how it goes up and then press down.
so just say,
Horizontal.
I got my new value.
I have other things to do, you just show the problem. Let's get straight to it.
One was 46.
Alright, you want me to like 3 to 3 to 5, and then but wait around for an hour because then the next hour or for the next 2 hours you want me to be talking. You want me to stay there for let's see 5 hours. 5 hours? That's like 4 hours of sleep. Then like hours of sleep. Like no, 4 hours of cheering and then 4 hours that I can sleep. No, I'm not trying to like. You also have homework. And then
Why is it so long to, again, why is the end of the
That's the only thing you can do to change where
There's
you're
only gonna be 3
looking.
of them, which does not count because I don't like Allison.
That's all it does.
So I don't trust her.
But like I said, you guys can scroll through a lot faster than I can. That's really all it does. Yes, ma'am.
Wait, I was so confused, like you just put like a route 46 or
Yeah.
like 100, but it's like is it a label like anything, like it's just 46, like just the
Feet,
number, like-
because it's talking about distances in feet, that's all.
Okay, thank you.
Yeah.
46 feet
Okay.
long.
Let's look at another one.
I get how to do that.
Yeah, oh yeah, we didn't talk about these yet.
Oh yeah, I can do that.
Did you guys figure out the volleyball with initial velocity stuff?
No.
Okay. Let's talk about that real fast. These are very, very easy style problems to work with. When you're dealing with this initial velocity, when you're dealing with this thing called initial velocity, you have one of two things. Initial velocity for an object dropped is modeled by that negative 16 t squared plus the height that the object was dropped at. I dropped it.
On your foot.
So that's how you can calculate the initial velocity. Alicia, you want to throw me?
Yeah.
The other one is that you're putting something in motion with an initial horizontal velocity. So it's going up and coming down as opposed to dropping something. Okay? There's a difference. Any of you guys in physics right now? Physics deals with a lot of this stuff, where it's the practical application of that. One of the things that you guys might have done with Sev last year.
No.
Did you guys do the velocity problem for the golf club?
No.
No?
I had you.
No, it's where you can actually there's a geometry thing where you actually can calculate the initial velocity coming off of that. It's a problem in the geometry book.
It's right
I
there.
did my best not to chips the floor. So, what's that?
It's right
I think so. It's a very, very old club.
here.
But anyway, there's these two formulas that work with this, and it's just a straight quadratic. You have initial height, some time in seconds, and an initial velocity, which is in feet per second. These are very, very easy to work with. So if I go back and I look at the volleyball problem,
How long did it take you to make this?
5 minutes maybe.
Really?
Yeah. And if I look at just this straight, the volleyball problem here, and walk you through how, here, you can throw it back.
Here she goes.
Gently. Fixate in the beauty.
Aw.
When you try your best, be
Anyway.
succeed.
In the volleyball game, player on one team spikes the ball over the net when the ball is 10 feet from above the court. The spike drives the ball downward with an initial velocity of negative 55 feet per second. Players on the opposing team must hit the ball back over the net before the ball touches the court. How much time do the opposing players have to hit the spike ball? Anyway, so you're trying to figure out this time value. This t value is what you're trying to solve for. Now, if I'm looking at this t value, was this ball dropped? Or was it hit with an initial velocity? So therefore, I'm going to use that second question of second model. That's 16, that negative 16 t squared. So the height equals negative 16 t squared plus your initial velocity. That's what v sub o stands for. Times t plus your initial height.
Oh, this is T.
Excuse me.
What is the T?
T is time. Yes, ma'am.
Are we gonna have any questions like that on the test?
I don't know yet. I haven't written it.
Okay, are we gonna get any of those equations or no?
Yeah, you should give us
You should give us like this cheat sheet.
I think sometimes with the initial height stuff, I think I have given the model, but I don't tell you what everything stands for. I think that's fair.
Yeah.
Whereas you have to know what it stands for and how it works. I think that's pretty reasonable. Okay. So if I'm working on this one, excuse me. We look at this one then. What is your initial velocity?
Negative 55.
Okay. So as we start to fill this in, we pick up on a couple of things. Negative 16 t squared minus 55 t.
Why is it T at the end?
Because that's what you're solving for. T is the time that we're looking for.
But why is it 55 T?
Because initial velocity times time.
Oh.
Okay.
It's the-
And now the last part there is what was the initial height it was hit from?
10 feet.
10 feet. So this right here is basically your quadratic that you're working for. So you're trying to solve for t in this case. There's one of two things you can do. You can try and factor it. What times what's negative 160 you add together to get negative 55? Exactly. Or one of the quicker ways of doing this, you could use your calculator, look for zeros, or you can use quadratic formula.
Quadratic formula for
I'm going to go with quadratic formula in this case. And there's a reason why. The numbers aren't that messy. And it's just, using your calculator. Yes, ma'am? I'll get you some, no problem. So what I want you to do real fast here is remember the quadratic formula is, let's sing it, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So take a second, take out all of your coefficients, and let's try and use quadratic formula here, and I want you to see what you get. Hopefully you'll recognize something.
Get out of here, Diggy. Good. Get out of here. Diggy back. Diggy back. Diggy, get out of here.
Oh, I'm gonna go back and watch it tonight so I can see if I can hear you say that.
that it's computer. Can't even say it down. I really hope he's good.
So let's see, we get 55 plus or minus the square root of 55 squared. Oh, what's the reason why I'm just writing it as 55 squared? Not negative?
No, it's already
Because
negative.
it's squared.
Minus 4 times a, which is negative 16, times 10, all over 2 times negative 16. I'm going to rewrite that as negative 32. That's easy. So in my calculator, I'm going to do, let's see, 55 squared minus 4 times negative 16 times 10,
Yeah.
and hit enter. I get some crazy number. 3665. Okay? So now I have 55 plus or minus the square root of 3665 divided by negative 32. Now remember, this means there are two zeros here. One when you add them and one when you subtract them. You have 55 plus the square root of 3665 divided by negative 32.
You can't shorten that.
And then you have 55, I don't think you can, minus the square root of 3665 over negative 32.
If I just write the plus or minus.
Well, here's the reason why I'm rewriting it out here. Because one of these values is going to be positive, and one of these values is going to be negative. Can you have negative time?
No.
We're not doing 88 miles an hour in a DeLorean, correct? Thanks. Thanks. Thanks.
I understand.
I didn't pay attention.
So if I do 55 minus the square root of 3665, I'm getting a negative number. Does everybody see that? If I divide that by negative, was it 32?
Yeah.
I get a positive number. Uh-oh, syntax. Uh-oh, what'd I screw up? What'd I hit?
Spaghetti.
Oh, I hit minus. Did I hit minus?
Yeah, no.
Yeah, I did. Okay, we did it back. I get 0.17 seconds. So if somebody spikes the ball, they have 0.17 seconds to respond. Now, again, the reason why I'm only using the subtraction version here is because if I use the positive value, 55 plus square root 3665, hit enter, divided by negative 32, I have negative 3.6 seconds. There's no such thing as negative 3.6 seconds. Okay, so I'm looking back in terms of what really makes sense. Could I have done that with the calculator and got my zeros and done the same thing?
Yeah.
Sure. But I think sometimes I like to show you guys the other ways of doing it. Quadratic formula is always a viable means to solve these things out. Okay? Not so bad? Which one? The length in feet of a runway needed for a small plane to land is given by that, where S is the airplane's speed in feet per second. The pilot is landing a small airplane on the runways that's 2,000 feet long. What's the maximum speed at which the pilot can land? So basically what you're doing is you're setting this equal to 2,000. I'm going to use X so I don't screw it up. And what you want to do is find the maximum speed. So set that equal to 0 by moving the 2,000 over. You get that, right? And then did you just find the maximum of that?
No.
What'd you do?
Oh, yeah.
Yeah. So in here is asking about the maximum speed. So what we're doing is we're putting that, once we get that set equal to 0, we go right to our calculator and we're going to calculate the maximum. Because that would be the highest value of that would be the highest, or the x value to generate the highest y, which would be what we're looking for.
Let's see.
Very, very, very simple to work with. The other stuff that I had for you guys, I'm just letting you guys continue to work through these things and stuff. Did you guys do okay on those cost ones?
Wait.
So much for this one, so much for
Can you
that
finish
one?
this one up real quick for me?
Wait, my
Yeah.
graph not showing up.
Yeah.
Change your graph, change your window, search for it. It should be in there.
I'm looking.
I'm searching.
You know you have an x-intercept at negative 1978.
Oh, snap.
Mr. Murphy, do you remember that?
I'm searching.
I'm gonna go with negative 2,000.
When you said there was a right angle, and you said no, there wasn't.
And then you like zoomed in
And you circled it.
on your
Nice.
screen, and you circled it, zoomed in, and you're like, I'm searching.
That was funny.
It really was, but it's also scary at the same time.
We get anything?
I can't find it. It's hiding.
It's hiding.
Make everything 2,000.
Okay.
2,000 is not gonna work. I don't think. It might actually. It might still listen to me.
Oh, I found it.
Did you really?
Haha. Now it's all of it.
Does 2,000 work?
Yeah, kind of, but it looks really ugly.
Does it fit the whole thing?
No.
Well, you probably know the
You probably the Y value. You probably
Go to
can move as well.
12,000. Go to 12,000.
And here's the thing, if you can't find it in the calculator, go back to quadratic formula.
Oh, I don't think
True.
Quit.
So if you go back to quadratic formula, it's relatively quick because you're just looking for a positive value. All right? So the idea is if you can't find it right off the bat in your calculator because the window range and all that stuff gets all messy, you can always fall back on the quadratic formula.
It won't let me.
So what I'm going to do here is figure out what's underneath the radical first. So we had 9 minus 4 times 0.1 times negative 1978. So 800.2. So it's 3 plus or minus the square root of 800.2 over 2 times 0.1. Yeah, so divided by 0.2. When I look at this problem, can I have a maximum speed that's negative?
No.
Nope. So am I going to do the add the root or subtract the root for this one? Add. So my answer is going to wind up being 3 plus the square root of 800.2, hit enter, divided by 0.2. 4. Go 2 decimals.
Yeah, okay.
You'll learn.
4.
So 156.44 miles per hour, I believe is what our units were. To be honest with you guys, if you forget your units, I'm not going to throw things at you. I might just, hit you with 4 iron, or 8 iron, actually. But,
Point.
What's that?
Mr. Sev, if we didn't put a unit, we put chickens with a question mark.
Chickens.
Yeah, Seth does that. I've known him forever. Did I tell you guys I went to college with him? I went to
Did you
college?
get him a job here?
Yeah, I got him a job here too.
I remember
Give
that
me a
story.
job here.
I wouldn't want to work here.
Do you need a job?
Yeah.
I don't know if they're hiring high school kids right now. During the summer you can get a job here and mow the lawn.
No. Nothing.
I do that. No.
I don't know.
No.
Really?
Do you get the tractor thing? Do you get the
It
tractor?
does not seem like fun.
Is it a push one or is it?
So, what I gave you guys, what was the cost problem you want to look at? Because I know I gave you a couple of them on there yesterday, while we have time. The stuff I gave you here today was basically everything else we've done. Okay?
Wait, I've got a question. You did like the plus, but how did you know that the plus was gonna be the one that worked like instead of the?
In terms of what the problem was looking for, I was looking for the maximum speed, and you have a negative speed.
No.
That's why.
But the last time wasn't it like the minus was the one that worked?
Because it was divided by a negative.
Okay.
So you start to look at what the problem's looking for, and you'll be able to pick out, okay, even if you did both of them, then you'd stop and go, oh, I can't have negative speed. I cross that off and just circle the other one. And if you want to do that, that's fine. Okay. On here, I don't know, was there another one of the
when's the next hour?
Yeah, and then I also don't know 99 or like.
Just solve them. Really positive then.
Or no, not 99. Yeah.
We did 99 yesterday.
Yeah.
So
I
guys,
was talking about-
ladies and gentlemen, like I was saying, the stuff that I just gave you, it's just a bunch of review questions off of everything we've done. It says solve by factoring, solve by taking the square roots, solve the quadratic formula, use by completing the square, find the discriminant, what kind of solutions does it have, simplify with your complex numbers, sketch a graph, simplify with to rationalize your complex roots, and then the last page I hand wrote in some write the equations, what we did 2 days ago. And on the very back page, there's your solutions. You can check your work. All right? So I plan on going through this stuff tomorrow. Probably just going to kind of start going at the top and just work my way through it. Okay? I will also still answer questions about anything lingering on the word probs. The test itself, still Friday. I'm trying to think about the whole. It should still be calculator, non-calculator. The non-calculator would be a graph, whether it's in standard, regular, or vertex form, get axis of symmetry, something like that. We'll go from there.
What's not going to
Finish this and this.
What is it?
By Friday,
I mean, part of it is the way
we got a couple of days. All the answers are there. It's nothing really all that new. Okay. Did you want me to, while we have a minute or two, you want me to go through the home electronics, sell the cameras problem
Yeah.
with the
How do you
cost
find-
problem?
How do you find the square root? Like using the calculator again? What do you-
This way you find a square, you take that number, like 90, divided by x squared.
Okay.
And then you look at your table. I'm going to go through the electronics one because that is another one of those cost problems. Manager of a home electronics store is considering replacing the model digital camera at the current price of $680. The store sells about 70 of them a month. Sales data from the other stores indicate that for each decrease of $20 in price, 5 more cameras per month will be sold. How much should the manager charge for a camera to maximize his monthly revenue? What is the maximum revenue?
10.
So you have cost and sales. Your initial cost was $680. At $680, how many did you sell?
20.
20 of them. Good. Nope. 70.
Or yeah, 70.
I'm like, wait, no, that's not right.
I think I'm just less 20.
So now you have, the next part is the decrease in cost. It says for every $20 in decrease in cost would be minus 20x.
10 plus 5.
It's minus because it's a decrease.
Oh.
The value of x means if x is 1, you're decreasing it by 20, 2, it's 40, 3, it's 60, and so on. That's what that means. And then it says sales go up by 5. Now at this point, a couple of things you can do. If you want to find your zeros, find your axis of symmetry, and then you can get your vertex, and you're basically done. Or you can go to your calculator and find the maximum value. It works the same. Okay? So if I go and do the calculator, which most of you guys would do, I go back to my y equals. It was 680 minus 20x.
Oh, no.
Let me start that. 680 minus 20x. And then 70 plus 5x.
Yes.
Thank you.
Yeah, what did you have? That's what I got too.
That's not what I got.
What's your Windows on there?
My window's all messed up right now.
Mine's-
Because what I want you to think about, what is your constant here? You got 680 times 700 times 70. So it's going to be way, way up. Okay?
Yeah, it's 10.
Okay.
57,000.
So your maximum
57,000.
would be what, 15,000-ish?
That's
How do you know that?
Put that in a minimum.
Yeah.
Oh, that's fine. How do I know that? think about what this means if you multiplied it out. You multiply this out, you FOIL that out, you're gonna get 680 times 70 plus 680 times 5x minus 20x times 70 minus 100x squared. It's just another way of doing it. Obviously, if you go that route, you have to mess around with your window to find the maximum, but it is all attainable.
Can't you just look in your table?
You can look at the table too, but sometimes it can be an in-betweener, so you gotta be careful when you look at your table.
In between.
Wait, so
Is
it's
there-
10? What is 10? 10 is 5,700.
What were you gonna say?
Is there another way to do this problem other than to
In this case here, this is a nice one that sets you up in intercept form. You can find your intercepts.
The answer is so sweet.
680 divided by 20, when you solve for, we set it to equal to 0. You get positive 34. 70 divided by negative 5 would be
Wait, what would be the
14, negative 14.
how much did the manager charge? Why is it negative 14?
Set this equal to 0, solve for x. Subtract 70 divided by 5.
Oh,
What happens between negative 14 and positive 34? What's the halfway point? It would be 10. So my axis of symmetry is at 10. So I take 10 and I substitute in, and that'll give me my maximum revenue. Okay? Remember, guys, using the graph, guys, using those different methods, a lot of times when they set you up with this cost style problem, it really is easier to go to your intercept form and look for the axis of symmetry, because that'll be the x value that it gives you a maximum and or a minimum. It's a little bit faster if you want to go that way. I'm not going to say you can't use a calculator, just so you know that. Thank you.
So would 10 be the maximum?
Once